Dividing fractions is similar to multiplying fractions. The main difference is that we first need to manipulate the original expression. The way we do that is fairly straightforward. We leave this first fraction alone, we change the sign to a multiplication symbol, and we flip the order of this fraction. So this original expression ends up becoming 3 over 8 times 6 over 5. These two expressions are equivalent, they're the exact same thing, but we know how to multiply fractions already. So if we set it up this way, there are two approaches that we can solve this problem. We can either do it the lazy way and multiply the numbers from left to right, or we can simplify those fractions first. So I'll go ahead and do it the lazy way, just because I expect most students to do it this way already. 3 times 6 gives me 18. 8 times 5 gives me 40. But now we need to simplify this further. So what number goes into 18 and 40? That would be the number 2. So we can divide both the top and the bottom by 2. 18 divided by 2 gives us 9. 40 divided by 2 gives us 20. 9 over 20 cannot be simplified any further, so this ends up being the final answer. This problem is pretty straightforward. We have 13 over 15 divided by 7 over 10. So we're going to keep this first term alone. We're not going to do anything to it. We're going to change this division sign to a multiplication sign. And because we do that, we need to flip the order of the second fraction. When we do that, we end up with 13 over 15 times 10 over 7. I'm going to actually simplify the diagonals. In this case, 10 and 15. What number goes into both 10 and 15? Well, that would be the number 5. So we can divide both of these by 5, and we end up getting 2 over 3. So instead of a 10, I'm actually going to replace it with a 2. And instead of the 15, I'm going to replace this with a 3. So if I look at my other diagonal, I have a 13 and a 7. That cannot be simplified. So at this point, we can just multiply the numbers from left to right. 13 times 2 gives me 26 for the numerator. And in the denominator, we have 3 times 7, which is 21. This fraction can't be simplified any further, so it is our final answer. This problem can seem a little tricky at first because there's only one fraction and students tend to flip this fraction around to become 2 over 3. But that is incorrect. Most of the time that we're dealing with fractions, it's a good idea to turn everything into a fraction. So before we start flipping any numbers around, we want to turn this whole number into a fraction. We want to turn this 9 into a fraction. When we do that, it becomes a 9 over 1. So far, we have 2 over 3 divided by 9 over 1. Notice that I haven't flipped anything around yet. Now that we have the original expression rewritten, we can follow the same pattern as before. We're going to leave this first fraction alone, so it's going to stay 2 over 3. We're going to change the division sign to a multiplication sign, and now we're going to flip this fraction around, so it's going to become 1 over 9. This is the proper setup to work the problem out. And if we look at my diagonals, there's nothing to simplify. You can't simplify 1/3, and you cannot simplify 2 over 9. So now we can just multiply the numbers from left to right. 2 times 1 gives me 2. 9 times 3 gives me 27, and I'm done with the problem. This problem is similar to the last. The only difference is that my whole number comes first. So again, before I start flipping anything around, first I'm going to turn everything into a fraction. So I'm going to turn the 6 into a 6 over 1. If I simply rewrite this to look a little better, we have 6 over 1 divided by 5 over 3. Now I can start manipulating the expression. So again, we're going to leave this first fraction alone. That's going to stay as a 6 over 1. Instead of a division, we're going to multiply, and we're going to flip this second fraction to become a 3 over 5. At this point, we can look at the diagonals to see if we can simplify anything, and in this case, we cannot. So we just multiply the numbers from left to right. 6 times 3 gives me 18, and 1 times 5 gives me 5. So 18 over 5 is my final answer. This last problem introduces negative signs, so it's important to keep track of the negatives. Because we have a fraction in this problem, we want to make sure that everything is a fraction. That means we want to turn this negative 10 into a fraction of negative 10 over 1. If I just rewrite this expression to make it look a little clearer, we have negative 9 over 5 divided by negative 10 over 1. Now that I have my expression rewritten, we can go ahead and manipulate it. So we're going to leave this first fraction alone. Again, we always leave the first one alone. We're going to change the symbol from division to multiplication, but because we do that, we need to flip the order of this last fraction. So it's going to become 1 over negative 10. So we have our expression rewritten. Now it's a matter of multiplying the fraction together. If I look at my diagonals to see if we can simplify anything, we can't. So we go ahead and multiply the numbers from left to right. Negative 9 times 1 gives me negative 9. 5 times negative 10 gives me negative 50. So we have negative 9 over negative 50, which isn't necessarily wrong, but the problem does want us to write it in simplest form. A negative divided by a negative is going to result in a positive answer. So my final answer is actually 9 over 50, and the answer is positive. This problem does ask for a mixed number, but because our numerator is smaller than the denominator, we don't need to worry about that. 9 over 50 will be our final answer.